I'm still a bit confused, dude. If you could, in a sentence or two, explain to me again. So, we've got the interstitial cells of Cajal. I don't know how they act as specialized pacemaker cells. We've got individual cells joined with gap junctions to allow electrical coupling. I don't get that either. And gap junctions enable groups of most of cells to act as a single functional unit or functional syncytium. So explain this in simple words, please.
Interstitial cells of Cajal, ICCs, are like the gut's metronome, sending out rhythmic electrical signals that tell smooth muscle when to contract, keeping food moving smoothly. Gap junctions are tiny tunnels between muscle cells that let electrical signals zip through, linking cells so they work together as one big team, called a functional syncytium, for coordinated gut contractions. Want me to clarify anything specific or move to motility disorders?
Tell me about basal electrical rhythm.
The basal electrical rhythm, BER, is the regular, spontaneous electrical activity in the GI tract smooth muscle, driven by interstitial cells of Cajal, which sets the pace for contractions like peristalsis, typically at 3 12 cycles per minute, depending on the region, like 3 in the stomach or 12 in the duodenum. These slow waves don't always trigger contractions, but determine their maximum frequency, coordinating motility to move food efficiently. Want to dig into how BER changes in disorders like gastroparesis or connected to gap junctions?
Let's talk about enteric nervous innervation connected to nutrients, stretch, pH, and osmolarity.
The enteric nervous system, EN, a network of neurons in the GI tract wall, controls motility and responds to nutrients, stretch, pH, and osmolarity to fine-tune digestion. It uses sensory neurons to detect nutrients like fats, triggering CCK release, stretch from food activating peristalsis via the myenteric plexus, pH changes prompting secretin secretion, and osmolarity shifts adjusting motility, ensuring smooth food movement and digestion. Want to explore specific ENS reflexes or motility disorders tied to these triggers?
I want to ask about how my enteric plexus is for motility and submucosal plexus is for secretion and blood flow.
The myenteric plexus, located between the muscle layers of the muscularis externa, controls GI motility by coordinating smooth muscle contractions for peristalsis and segmentation, driving food through the gut. The submucosal plexus, in the submucosa layer, regulates secretion of digestive enzymes and mucus, plus blood flow to support digestion and absorption, working with the myenteric plexus to sync motility and nutrient processing. Want to dive into how these plexuses respond to stimuli like stretch or nutrients, or explore related disorders?
I want to ask you about the autonomic nervous innervation now. So we have parasympathetic and sympathetic.
The autonomic nervous system regulates GI motility through parasympathetic and sympathetic innervation. Parasympathetic nerves, mainly via the vagus nerve, boost motility by enhancing peristalsis and secretions, promoting digestion, while sympathetic nerves, from thoracic splanchnic nerves, slow motility by inhibiting contractions and tightening sphincters, often during stress. Want to dive into how these interact with the enteric nervous system or their role in specific GI functions?
Yeah, I want to understand their role, to be honest. So how come the parasympathetic is to do with excitatory to motility and secretion and to innervated, gets innervated by the vagus and sacral nerves, while acetylcholine and with acetylcholine and sympathetic is inhibitory to motility and secretion, thoracolumbar nerves innervated, and then norepinephrine.
The parasympathetic nervous system boosts GI motility and secretion by releasing acetylcholine, mainly through the vagus nerve for upper GI and sacral nerves for lower GI, exciting smooth muscle contractions and gland activity to speed up digestion. The sympathetic nervous system, using norepinephrine via thoracolumbar splanchnic nerves, inhibits motility and secretion by relaxing smooth muscle and tightening sphincters, slowing digestion during stress or fight or flight responses. Want to explore how these balance with the enteric nervous system?
Thoracolumbar.
Hey dude, I hear you. But you mentioned sticking to English, so I'm gonna keep it there. Sounds like you're asking about the thoracolumbar column or nerves, maybe tied to our sympathetic nervous system, chat? The thoracolumbar nerves, T1, L2, carry sympathetic signals to the GI tract, releasing norepinephrine to slow motility and secretions, acting like a brake on digestion during stress. Want to clarify if you meant something specific about the
Yeah, I was
thoracolumbar?
wondering why it's the fucking thoracolumbar, dude.
Fair question. The sympathetic nervous system's thoracolumbar nerves are called that because they originate from the thoracic, T1, T12, and lumbar, L1, L2 regions of the spinal cord, forming the thoracolumbar division that sends inhibitory signals to the GI tract, slowing motility and secretions via norepinephrine.